Hydroprocessing is a common refinery process operation and consists of the two extremes of hydrotreating and hydrocracking. The difference between the two is that hydrotreating seeks to remove objectionable materials without changing the boiling point of the material being treated. On the other hand, hydrocracking is a more severe operation that also cracks the feed material into smaller molecules. This doesn't happen in hydrotreating. Hydrotreaters have two primary purposes: remove potential catalyst poisons and/or remove sulfur. For example, there is always a hydrotreater before a catalytical reformer that exists to remove material that might poison the reformer platinum catalyst. On the other hand, if the principal purpose of the hydrotreater is to remove sulfur compounds, it is often referred to as hydrodesulfurization, or HDS for short. The reactions occurring in hydrotreating are complex. The major ones are to saturate olefins, which often produce gums otherwise, and to convert sulfur that are attached to hydrocarbons to hydrogen sulfide. Hydrodesulfurization is often carried out on diesel feed streams to reduce sulfur levels for use as a motor diesel fuel. One often hears the term ULSD, or ultra-low sulfur diesel. In fact, the flow sheet shown here is for an HDS that will clean up diesel to be used as a motor fuel. The hydrotreating reaction is carried out between 500 and 800 degrees Fahrenheit and at pressures between 500 pounds per square inch and 2,000 pounds per square inch. The combination of temperature and pressure determines the reaction severity. It should be noted that the reaction consumes hydrogen, which is in short supply in a modern-day refinery. The process flow is actually quite simple. Feed material is combined with hydrogen and heated in a furnace before entering the reactor. The reaction is exothermic, that is, it produces heat. The outlet of the reactor exchanges heat with the feed material before vapor and reaction product are separated in the separator. A portion of the vapor stream is bled from the unit to remove impurities, while the remainder is combined with makeup hydrogen before being compressed back up to reaction pressors in a reciprocating compressor. The liquid from the separator is fed to a trade stripper where hydrogen sulfide and other light gases are separated from the feed material. It is similar to a distillation column in that it both has a reflux stream and reboiler. However, there is usually no overhead draw material. Clean diesel exits the stripper after exchanging heat with feed material.